Okay, with MATLAB open, do me a favor and type the word true. T-R-U-E, hit enter. And you see we get an answer of 1. Type the word false, F-A-L-S-E, and hit enter. And you get the answer 0. MATLAB evaluates true as the number 1 and evaluates the word false as 0. And it can evaluate certain logical statements and execute lines of code if a logical statement is true, or skip lines of code if a logical statement is false. So in this video, we're going to learn about selection. We're going to use logical statements to determine whether or not we should execute lines of code. Okay, let me clear the command window and clear the workspace. Now suppose I have a variable a, and we'll set a equal to 4. Okay, there's a, and now I can perform some logical tests on this variable. For example, I can ask, is a less than 0? So I will type a less than 0, and I'll hit enter. Okay. Of course, that statement is false, so it returns an answer of 0. I can ask, is a greater than 0? And that statement is true, so it returns an answer of 1. Okay, now in your book is a table of all sorts of different logical operators. So we used 2 logical operators here, less than 0 and greater than 0. You can also try a less than or equal to 0, or the less than or equal to, a greater than or equal to, okay? And it doesn't have to be 0. We can test if this thing is less than 4. Is a less than 4? Well, no, it's not, so that will return 0, false. But we can also ask, is a less than or equal to 4? Yes, it is, right? So that evaluates to true. Okay? We can test if something is equal to a value. So for instance, we can ask, is a equal to 4? Okay, notice here I'm using the double equal sign. So a double equal sign is to test for equality, while a single equal sign is used to assign a variable to a value, or a value to a variable. So this is the cause of many semantical errors here, using a single equal sign versus a double. Again, a double equal sign is used to test for equality, while a single equal sign is used to assign a value to a variable. So I will test, is a equal to 4? Yes, it is. So it returns logical true, or logical 1. Is a equal to 3? No, it's not. Okay. The tilde means not. So I can say, hey, is a not 3? Not equal to 3? Yeah, that's true. A is not 3. Okay, I'm going to clear the command window. I can say, is a not equal to 4? No, that's false, because a is 4. Okay. These kinds of ideas also work for vectors, and here's really the power of MATLAB again. Remember, matrix laboratory. So let me take a vector, let's call it v. V equals, and I'll just give it 4 elements there. -10, I guess I need a comma. I'll put a comma there. -10, 11, 62, -39.4, and I'll hit enter. There's the vector. And I can compare all of these values to a constant or a scalar at once. For example, I can say v less than 0. And look, it returns to me 1, 0, 0, 1. That means the first element is indeed less than 0, or true. The second element is not less than 0. The third element is not less than 0. And the fourth element is less than 0. So that's true. Pretty neat. Let me take another vector. Let's call it A equals, and let's do that guy. Negative 11, 52, negative 80, 72. Okay, so again, this works the same way. I can ask, is A less than 0? And it returns to me 1, 0, 1, 0. That means the first element is indeed less than 0, and the third element is indeed less than 0. I can also use what's called a Boolean operator, which is and or. So for example, I can ask, I can say v less than 0, and I'm going to use an ampersand, a less than 0, and hit enter. And I get 1, 0, 0, 0. So this is asking, hey MATLAB, where is v less than 0 and a less than 0? Well, that's only the first element. The first element of a is less than 0, and the first element of v is less than 0. There are no other elements in which a is less than 0 and v is less than 0. I can also ask MATLAB to find where v is less than 0 or a is less than 0. So this is the vertical bar, shift slash. Hit enter. So notice in this expression here, 1, 0, 1, 1, where is v less than 0 or a less than 0? Well, that's in the first element, where they both happen to be less than 0, not the second element, because they're both greater than 0. The third element, in which a is less than 0, and v is not, and the fourth element, in which v is less than 0, but a is not. So I get 1, 0, 1, 1. Okay, this works for scalars as well. Let me clear the command window, CLC, and I will clear the workspace. Let's say I have a scalar, a equals 5, and b equals 3. I can ask, is a greater than 1 and b greater than 1, for example. A greater than 1 and, now I'm going to use it double ampersand, b greater than 1. The reason I need a double ampersand is I use double ampersands for scalars and single ampersands for vectors. So because a only contains one value and b only contains one value, I only need I need a double ampersand there. I'm only checking one value. I hit enter. It says yes, that's true. A is greater than 1 and b is greater than 1. Let me ask, is a greater than 3 and b greater than 3? It says no, that's not true. Okay, and that's because, of course, b is not greater than 3. I can ask, I can use the double or sign, the double vertical bar. Is a greater than 3 or b greater than 3? Hit enter. Yes. Okay, and that is, of course, because a is 5. So that evaluates to true. And so one or the other is definitely true, so it's 1, so it's true. Okay, let's use this idea for a first example I want to write some lines of code that convert or takes the absolute value of a vector. Okay, so let's go back to v. There's v. And suppose I want to take the absolute value of each element in that vector. Okay. Now what I can do is ask the question, is v less than 0? Okay. So let me start with that, and I will call that vector tf for true-false. So I will say v less than 0. Okay, I'll put a semicolon after that. Okay. Now at this point in the video, you should be able to tell me what is stored in variable tf. So I'll type tf, and in a second I'm going to hit enter. Think about what it's going to give me here. 1001. Is that what you predicted? Okay, it's 1 here because that's where v is indeed less than 0. And it's 1 here because v is less than 0 as well. Now, if I were to take -2 times tf, okay, dot times v plus v, I would get the absolute value. Let's think about that for a second. So first of all, I need a dot times, because remember, dot times takes the element, that's an element by element multiplication. So that's going to take each element in tf times its corresponding element in v. Okay? So if tf is false, right, if it's 0, let me write it over here. So I've got -2 times tf times dot times v plus v. So if this happens, if tf is 0, then this whole expression is 0, and I get v. Okay, that's if tf were 0. Okay, in other words, if v was not less than 0, I get v back. Okay, that's exactly how the absolute value is supposed to work there in that case. Again, when v is not less than 0, so this is false, this whole term is 0, and I get back v. Now in the event v is less than 0, tf is 1, and I get -2 v plus v, and so that's equal to -v. And that's in the event where tf is equal to 1. So now when v is negative, I get -v, which makes it a positive. So this is one way that I can implement absolute value. So I push enter, and yep, I see I've got the absolute value of each element in v now. Okay, make sure you pause these videos if you feel like you need to absorb that a little bit more. Okay, let me clear the command window and clear the workspace. Now, let me show you another way we can implement the absolute value function. So what I'm going to do is create a function, and I'm going to call it my absolute value, my ABS, and I'm going to delete the end of the function because that's optional. Okay. And for this function, so this is a slightly different example than the previous absolute value. For this function, it's going to take a scalar. So I'm going to give it a scalar, -5, for example, and it's going to output another scalar that's the absolute value of the input. So let me call this input anything. Let's call it lowercase x. And the output, let me call that x underscore out. X underscore out. I will describe the function my ABS takes a scalar as input and returns the absolute value. Absolute value as x out. Okay, and I'll put my name there. Okay, I'll put the date. Last updated 4/27/17. Now, the great thing about logical operators is they can allow you to execute certain lines of code if something is true and bypass certain lines of code if something is false. The way we do that is with if statements. If statements. Okay. And each if statement needs an end. Okay. If is a key word. Okay. When you type if, it shows up blue, and you don't want to use if for anything other than using an if statement. For example, you don't want to call a variable if or call a function if. MATLAB would have a problem with that. That could be a semantical error. Okay, so the idea is this. If I want to write my own absolute value function, you give me x, and I give you the absolute value back. So for example, if you were to give me anything that's non-negative, okay, for example, you give me 1 at the input, I give you 1 back. If you give me 0 at the input, I give you 0 back. So for x greater than or equal to 0, okay, the function is x. And the function is negative x for x less than 0. For example, if you give me -1, I give you negative x back, I give you 1. If you give me -2 back, or if you give me -2, I give you 2 back. Okay, so that's the idea here. And I can use an if statement. I can say if x, and then use a logical operator. If x is greater than or equal to 0, then I'm going to set my output, x out, is going to be equal to x. And then I can say else. So this is kind of the default case. Else, I'm going to set x out equal to negative x. Okay, so let's do that here. In the editor window, I'm going to type if, and notice right away it turns up blue. Space. And now here's my logical test. So this is the if statement. I'm going to test x greater than or equal to 0. Okay. If that's true, if that evaluates to 1 or to true, then I'm going to execute the following line of code. I'm going to say x out equals x, semicolon. Okay. Else. Okay. Meaning, if that's not true, okay, then if the if statement in line 7 is not true, then I want to do something else. So in this case, I want x out to be negative x. Okay. And the if statement needs an end. You need to tell it where to end this test. Okay. So what happens here is we execute line 7. Okay. Line 7 is evaluated. Is x greater than or equal to 0? And based on that evaluation, true-false evaluation, I choose a block of code to execute. If I'm going to execute line 8, if that's true. Otherwise, I'm going to execute line 10. And then, so regardless of if it's true or not, I've defined x out. And so at the end of this function, x out is well defined, and the function passes me back x out. Okay, that's how it works. Notice here, I've indented. Okay, indentation is optional in MATLAB. Okay, but it's good programming practice to do so. And other languages actually require as their syntax that you indent inside an if statement. Okay? So if I've got an if statement, I want to indent everything that comes between if and else, and then everything between else and end. Notice also how the if, else, and end line up with one another. So visually, I can see that quick. I can say, oh yes, you've got your if, you've got your else, you've got your end. In fact, if I click on end, notice its if gets underlined. Did you see that? I'll do it again. If goes underlined. If I click on else, the if gets underlined. And if I click on if, the end gets underlined. Okay, so these things go hand in hand. They all match up together. Okay, so let me save that. Save it as my abs. Okay, there we go. So let me try it now. So let's say I want my ABS of -5, and it gives me back 5. Okay, let me try my ABS of 5. It gives me back 5. Let me try my ABS of 0. And it gives me back 0. Okay. The else statement is not required if you use an if. You do not need an else. Okay. The if only needs an end. It's required. You have to have it. In fact, if we got rid of the end, I think MATLAB tells us, yes. See, notice the if is underlined in red now, and we've got this red bar here. It says an end might be missing, possibly matching if. Okay, so we can get rid of that error by putting an end there. If I remove the else, okay, I get no such error. Okay, there's no error there. Now the code would not work correctly, but syntactually it's fine. Okay, I'm not breaking any MATLAB rules. An if does not require an else. Okay. And to demonstrate that, let me show you another way of implementing this function. Okay. So let's say you give me an x. Here comes my x. I'm going to say, okay, x out is equal to x. So at this point, you give me 5. I'm going to output 5. You give me 0. I'm going to output 0. But at this point, you give me -2, I'm going to output -2, which is not correct. So now I'm going to say, if x out is less than 0, then I want to change x out to -x out and end. Okay? Again, in programming, there are several ways to arrive at this correct answer. Here's another way of doing it. In this way, I did not use an else statement. The else is optional. Still need an end, though. Okay, so x comes in. I say, okay, I'm going to output x. But if that number was 0, I'm going to negate it, and then I'm done. Okay, so let me save it, and let's check it out. My abs of 5, okay, gives me back 5. Was the if statement on line 9 true in that case? No, it wasn't. My abs of -5 Okay, it gives me back 5. In this case, the if statement in line 9 was true. So I execute the code that's between if and end, which is this, to negate the -5 to make it a +5. And let's try my abs of 0. Was the if statement true here? No, it wasn't. Is 0 less than 0? No. So in this case, this line is bypassed, and I've reached, line 14 or 16, which is the end of the function. So we'll save that. And clear the command window, clear the workspace. Okay. The next thing I want to work through, the next example I want to work through is an example where we are measuring the diameter and the mass of a coin, maybe for a vending machine. Okay, so we put a coin into a vending machine, we measure its diameter, we measure its mass, and depending on whether or not the diameter of the coin falls within 5% error of the diameter of a nominal coin, and whether or not the mass falls within 5% error of a nominal coin, we output its value, okay, in dollars. All right. So let me open up a new function, and we'll call this coin value. Okay. So in this function, we're going to take the diameter as input, we'll call it D, and we're going to take the mass in grams as input. And we're going to output the value V of this coin. Okay, I'm going to delete the end, it's not necessary, and I'm going to describe this function, coin value outputs the value V of a coin given the diameter D and the mass M in millimeters and grams respectively. Okay, put my name there. Okay, and the date. Okay, and it's got to fall within 5% error. Okay, that's the key here. So, for example, if the diameter of a coin was 19.05 millimeters, and the mass was 2.5001 grams. Okay, that falls within a 5% error, and so we would still call that a penny or a small cent, and we would still output its value as 1 cent, $0.01. All right, so let's try it. Let's say if we'll take D, and we'll say if D is less than 1.05 times 19.05. So that's, if it's less than 19.05 times 1.05, so that's the upper bound. That's 5% higher than 19.05. Okay, so if it's less than 5% higher, and, okay, so D is a scalar, so I'm going to use the double ampersand here, and D is greater than the lower bound, which is 0.095 times 19.05. Okay. If that's true, then that passes the diameter test, okay, for a small penny. And if the mass, M, is less than the upper bound 1.05 times 2.50, and the mass is greater than the lower bound, 0.095 times 2.50. Okay, 2.50 is this number here, small cent. So if the diameter passes this test, it's within 5% error of 19.05 millimeters. And if the mass passes this test, okay, then it's within 5% error of 2.50 grams. And if it passes all of those tests, then it qualifies as a small cent or a penny. So then we would say value V equals 0.01. And then we can type else, and then give it another if, else if. Okay, so in other words, maybe it didn't pass that test. So we can say, well, else if, and then I can change the numbers around a little bit. Then let's test for a nickel, where the diameter is 21.21. So I'll change the 19.05 to 21.21, 21.21, and then change the mass to 5.00, 5.00. So if it passes, so if it did not pass the small cent test, okay, so that's where the else part comes from, then maybe it'll pass the nickel test. So if this is true, an indent, then V equals 0.05. Okay. And we can continue on this way. Else, if, so the dime has got a nominal diameter of 17.91 millimeters. 17.91 millimeters there. 17.91 millimeters, and a mass of 2.50. Okay, so if it passes that test, then I'm going to say the value is 0.10. Else, if, then I've got the quarter, which is a diameter of 24.26. 24.26, 24.26, and a mass of 6.25, 6.25, 6.25. And in that, if it passes that test, then we'll output a value of 0.25. Okay, and we can repeat this for the $half, which has a mass of 30.61, 30.61, and a mass 11.34, 11.34, 11.34, and in that case V equals 0.50, and then we can repeat this again for the dollar, the coin dollar, else if. And the coin dollar has a diameter of 26.50, 26.50, 26.50, and a mass of 8.10 grams, 0.10 grams, 8.10 grams. Okay, so if that's the case, we'll say V equals $1.00. And maybe if it fails all of those tests, maybe we'll say, well, the value of this, whatever that you're putting in then, maybe it's zero value, right? It's not really a coin. Maybe it's one of those pesky Canadian coins or something. So we'll say else. And we won't put an if this time, because, you know, if it failed all those, then we'll just say else. We'll say the value is 0.00, and then we have to end the if statement there. Okay, so our code might look like this, and I'll give it some comments. Comments are nice. Sprinkle in some comments. Test for penny. Okay. Test for nickel. Test for dime. Test for quarter. Test for half dollar. Test for dollar. Okay, and then maybe this is the default to 0 value. So I'll save that as coin value. Okay, it doesn't like this. Why doesn't it like this? Terminates. I don't know why it doesn't like that. Okay. So I've saved it. Now let's try it. So we'll say value equals, and we'll type coin value. And now suppose I get a coin that comes into my vending machine and it's perfectly a $half, 30.61, 11.34. So it has a diameter of 30.61 millimeters and a mass of 11.34 grams. So I'll send that to my function, and we'll look at the value. Value is perfect. It's a $half, 50 cents. Okay, now suppose I get another $half. Okay, but it's not quite nominal. Maybe the diameter is a little smaller. Instead of 30.61, it's 30.59. And instead of the mass being 11.34, it's a little smaller, 11.31. Hit enter. Let's take a look at the value that it calculated, and it still calculated it to be 50%, or sorry, 50 cents. So that coin, both the diameter and its mass, fell between a 5% error of the nominal $half. So it's still 50 cents. So I can try this, I can test this with a lot of different things here. But one thing I want to do is test, let's say I get something the size of a nominal penny, okay, 19.05 millimeter diameter, but it's got the mass of a dollar coin, 8.10 grams. Okay, so it's got the size of a penny and the mass of a dollar. So I'll type enter there, and we'll take a look at the value. So it output the value 0. So this particular coin, whatever it is, did not meet the test for a penny, did not meet the test for a nickel, and so forth. So it defaulted to a value of 0. And that's what we got. Okay, so in this example, we were using else if along with our if and our end. Okay, we're using else if. Else if is another keyword in MatLab. But it's not necessary. Remember, just the if and the end. The end is necessary if you have an if statement. Okay, let me clear the command window, clear the workspace. Okay, so finally, I want to give another example. And in this example, we're going to simulate a very simple dice game. Okay, dice game. Okay, we are going to roll 2 dice, and if the sum of the faces is 7 or 11, we're going to win. Hooray! Okay, otherwise, okay, we lose. Okay. Now, this could be done with an if statement. Okay, we're going to simulate our roles. If the sum is 7, win. If the sum is 11, win. If the sum is 2, lose. The sum is 3, lose. I want to show you a different way, which is using a switch statement. Okay, so I'm going to go into MATLAB. I'm going to write a new function, and we'll call this guy game. Game, and it's going to take 0 inputs. 0 inputs, and that's because it's going to simulate the rolling of 2 dice. So I don't need to give it anything. And it's going to output win, a variable win. And we'll say win, I'll describe the function here, game outputs 1 if we win, 0 otherwise. Okay, so the value of win is going to determine if we've won or not. So it's going to be a 1 if we've won, 0 otherwise. And I'll get rid of this end, which is optional for a function. Okay, so if you remember from the random video, I can roll 2 dice. I can say roll equal. Let me shuffle the random number generator first. RNG shuffle. Okay, then I'll say roll equals rand I maximum of 6, and I want a 1/2 vector. Okay. Let me put my name here, and let me put the date. Okay, so we'll say shuffle the RNG. Okay, roll the dice. Okay, now the sum S is roll 1. Okay, so that's the first component of our vector. That's holding the face on the first die. Plus roll 2. That's holding the face on the second die. So there's our sum of faces. Okay, so now we want to test S and compare it to 7 or 11. Now if you have a discrete number or a countable number of outcomes, of possibilities, okay, so 7, the sum can either be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's a countable number of outcomes. Compare that to the case if you're just trying to see if the sum is greater than 2. Okay, there are, or if you're trying to see if a number is greater than 2, there are infinite possibilities, right? It could be 3, it could be 4, it could be 4.596, it could be a billion. Okay, there are an infinite number of possibilities. You could not do that with a switch statement. If there are a countable number of possibilities, as is this case, you can use a switch statement. So I'm going to type switch, and notice it turns blue. Okay, when it turns blue, that means it's a reserved keyword for MATLAB. And I'm going to, it's like a mechanical switch, meaning I've got something, and it can be in one of several locations or orientations. The switch can be like this, 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 this. That's where the name switch comes from. Okay. So I'm going to tell it the variable that I'm comparing is S. So switch space S. Enter. And I'm going to say case. Okay. Again, case turns blue. It's a reserved keyword in MATLAB, and we're going to use it with the switch statement. Case. And then in curly brackets there, I'm going to type 7, 11, and then close the curly brackets. So this is the syntax. You need to use curly brackets for the case statement. So now we're saying, okay, if S is 7 or 11, okay, and this is the win. Woohoo! So I will say win equals 1. Okay. Now here we have some choices. We can say case 2, 3, 4, 5, 6, 8, 9, 10, 12. Win equals 0. Okay, this is a lose. Okay, that's fine. You can do that. Or you can type otherwise. And notice otherwise turns blue. Okay, that's a reserved keyword in MATLAB. So we've got 7 or 11, we win. Otherwise, we lose. And let me end the switch statement. The end is required. Before I had the end, notice I've got red underlining switch. And it says end might be missing, possibly matching switch. So yes, MATLAB, thank you. So I will type an end there. Notice that the end lines up. Okay, it's aligned with switch. Then after everything inside there is indented. The case is aligned with the otherwise. All of the cases would be aligned. And then inside each case is indented yet again. Okay, that's just good practice. Good programming practice there. I will save this as game. Okay, and let me test it out. Okay, now to see if it's behaving correctly, I also want to see the roles. Okay, so up here in my function, I'm going to take off the semicolon. Save it. All right, now I'm going to call game. All right, so the role was 2, 2, and it said answer 0. So the answer is I lost, because I rolled 2 and 2, which sums to 4. All right, let me try again. Game 3, 1, I lost. 1, 4, I lost. Clear the command window. Game 8, I lost. I rolled a 5 and a 2, and it says I won. Okay, so it looks to me like this function is working correctly. So I will put the semicolon back on to line 8, save it, and X out, call it a day. Right? All right. So let's summarize the key points here. First of all, true. If a statement is true, that evaluates to 1. If a statement is false, that evaluates to 0. Okay. We're going to use the evaluation to execute lines of code or skip lines of code using the if, switch, else statements. Okay, we looked at logical operators. Okay, so there we had an and, which was the ampersand sign. I'm not going to draw the ampersand sign. Every time I try to draw it, it ends up looking like a treble clef. There was the or, which was the vertical bar. There was not, which was the tilde. There was equals, which was 2 equal signs. 2 equal signs. there was less than, right? Ooh, that's greater than. There's greater than. And there's less than. Okay, I'll draw it. Here's my ampersand, and here's my or. Okay, and if we're going to use vectors, they require single ampersand. Single ampersand and a single or, and scalars require double ampersand and double ors. Okay. We also then looked at some keywords, some new keywords for us. Very important. Now we'll need these guys for the rest of the term. We looked at the if keyword. So if, and then you put a logical statement here. If, a logical statement. Okay. Then you indent, put some lines of code, and then you need an end. You have to, that's syntax. If the logical statement is true, then these lines of code will execute. If the logical statement is false, these lines of code will not execute, and it will just bypass those and continue on down the line here. Okay. You can also use else and if-else if you like. So you can have if, and then you put a logical statement, and then some lines of code. So if that is true, or you can say if that's not true, you can execute some lines of code. And then we still need an end though. This might get cut off in the video, so let me draw this again. So if a logical statement is true, execute these lines of code, else execute these lines of code, end. Okay, so if this is true up here, then we would only execute these lines and not these lines here. And if this is false, then we would not execute these lines and we would execute these lines. And then we would continue on if there was more code. Okay. Finally, we looked at the switch statement. A switch requires an end. Okay. And we're going to put the variable that we are comparing here. So in our game problem, that was s. We wanted to test s, see what value it has. Then we would use the next keyword, case. And we would put some cases here, separated by commas and inside squiggly brackets. And then if this variable and the switch statement is equal to one of these cases, then it would execute these lines of code. We could write other cases, or we could write otherwise, and it would execute these lines of code, and then it would end.